We did a factoring delta review, and those that know how to factor shouldn't have taken too long. Those that don't, you figure it out, man. We're going to be factoring off and on through all the way to probably till May. So just it's a skill. So we decided that's what you should do on this day. And then there's a third delta math now, which kind of pertains to what we're doing here today. So you have to get back on that. The delta math direction should be up here. You should be in though, and I assigned it to you. You should be in my class. I've already seen you get in there the day that I put you in here on November 4th and had you do it in front of me, just to make sure I saw your names pop in. So just log in and you'll see 2 more assignments, and we should get those done. So the one for factoring will be late and will be a little bit of partial credit. I think I took 10% off in the first year, but we just got to get going and doing the stuff. I can only keep saying it over and over again until I get everybody to do. At some point, the planets will align and everyone will do the assignments on a timely manner. It's going to be amazing when that happens. It's going to be just rejoice in the streets kind of thing, but we'll see. I can only hope. All right, so we do have a problem, and the problem is this: the idea, and this is all the great vocab and what we're going to be learning and blah blah blah, but we don't have much time here. So the problem exists when we can have a radical also in fraction format. Okay, or exponential format, which is a fractional exponent. So with that being the case, it creates a can of worms where we could actually have to deal with exponent rules while, we have these kind of questions. Carolina, you're making me dizzy. You're actually on the road right now? Okay. Okay, all right. That's going to be tough. I can't look at you because I'm going to get car sick. Okay, here we go. um, Product of powers. So we're going to have to know some exponent rules because it may end up happening with, fractional exponent rules. So what happens when I have, and I kind of have to zoom in on this so we could see this quite well, and maybe I'll take care of the 2 first rules right off the bat, is you add these exponents. Okay, that's what you do. So, the real simplistic, 8 squared times 8 to the third, we should know is 8 to the fifth. That's all that rule is. That's all we're saying there. And then this other rule right here, quotient of powers, this is the subtraction rule. Then I'm going to come up with some actually the subtraction rule of powers like this in this sense creates 2 more problems, creates 2 more properties of exponents. But let's tackle these first. So when you see 4 to this power times 4 to that power, actually you can handle this by adding the exponents. And then look at these exponents, they're fractional. Well, so what? Just to add these fractions, Lexi Samuelis can do that, my 10-year-old. You already got common denominators. 2 plus -1 is 1. So this is actually equal to 4 to the positive 1/3 power, just by doing the add exponents rule of numbers of the same base being multiplied together. Yes, this does equal the cube root of 4, but just leave it. When we have fractional exponents, and they want you to simplify leaving it in fractional exponents, just leave it alone. All right, and then we got some better questions later about this. Oops. Oh, why is my eraser still hitting here? Oh, great. I got something going on with my pen here. Geez. All right, great. We're getting got a lock up on my situation here. Gonna hit Control Alt Delete. Go back. Try to hit draw. Okay, it worked. Okay, this ends up just being 3 to the third. 6 minus 3, all right? 3 to the 6 over, really what's happening, 3 to the 6 is 6 3s multiplied together. 3 to the third is 3 3s multiplied together. Boom, boom, boom. You have 3 3s up in the top. So that's why it's subtract the exponents. Really like to show people that when we're looking at these rules here. All right, going to bounce back. Power raised to a power rule. When we have a to the m raised to the n, that is a to the m times n. So you multiply those exponents when you have a power raised to a power. Real simple thing for that, 2 to the seconds raised to the third, that becomes 2 to the sixth. That's all that rule means. But fractionally, when I have 7 to the third raised to the 2/3, sure, I have to multiply these two. I'm going to write it out here so the final answer could be in the circled. And makes me sad how many students don't know how to multiply fractions. The 3's cancel. This actually ends up becoming 7 to the 2/1, or 7 squared. This actually is 49. Instead of writing it as 7 squared, I think we can evaluate that. The previous one, I can't really well, I could have wrote 3 to the third is 27, so I guess so. 4 to the 1/3, that doesn't really evaluate. It's the cube root of 4. I need a calculator to get that decimal, so we're going to want to leave that one like that. But when you get 7 squared, I think we should be writing that as 49. I think we should understand that. Okay. You have a product raised to product raised to a power rule. So this just becomes a to the m times b to the m. All that means is you can distribute that power throughout that product and raise both parts of that product to that power. So this one becomes, I'm going to write this on the outside of the circle again, 16 to the 1/2 times x to the 1/2, because the 16x is all in parentheses, so it is both these raised to the 1/2 power. But the problem is, we should be evaluating this. What is 16 to the 1/2 power? It's not 8. It's the square root of 16. Thanks, Alessandra. I saw your hands go up there. I do appreciate that. It is 4. Right, so that simplifies, and we are going to want to simplify when we can on these kind of questions. So 4 times, and then x to the 1/2, that's the square root of x, but just leave it, x to the 1/2, because it started as a fractional exponent. Simplifying, we'll leave it as a fractional exponent, and only simplify like numbers if we can. All right, now, remember what I said about the division rule, creating 2 more rules. I really want you to know this because students often forget about this rule, screw it up, don't use it appropriately, or just, basically forget about it. And it really has to do with this. Just write this down real quick for the negative exponent rule. Write x to the third over x to the sixth. If you did the subtraction rule, you would do 3 minus 6, which is x to the negative third. Let's not just think like robots here. Let's do what I did in that one where I said, hey, actually probably a smarter way to do this one is to think about where are there more x's? And the answer to that is there's way more x's on the bottom. That's what x to the third over x to the sixth looks like written out. And then if I actually cancel these just like regular math, instead of using a silly division rule, I could see I have more x's on the bottom. I have 3 more. So what the heck just happened here? 1 over x to the third, and I did it a different way, and I got x to the negative third. It's because they're equal, and there hence is the negative exponent rule. The negative exponent rule exists only because of the subtraction rule of exponents when you're trying to simplify numbers of the same base being divided. So that's it. That's the negative exponent rule. That is the reason why a to the negative m is equal to 1 over a to the positive m. That is the reason. The reason is staring you in the face in yellow over here. Before I do another example of that, what about x to the third over x to the third? Everyone should know that x to the third over x to the third equals 1 because it's something over itself. But what if you robotically said, well, let's just do the subtraction rule and do 3 minus 3? Well, then I get x to the 0. And there you go again. You did something two different ways. You got two different answers. Those two different answers are exactly the same thing. And therefore, that is why we have the 0 exponent rule, where anything to the 0 power is equal to 1. Why? Right here. This is the reason, all right, so that you can solidify that rule and never forget it again. Same thing with the negative exponent rule. Okay, now, this is where this gets a little troublesome. This is the no calculator scenario. 36 to the negative 1/2. This actually equals, this, you don't flip a half, it equals 1 over 36 to the positive 1/2. Okay, and then that's the negative exponent rule in action. Okay, especially in terms of this, fractional exponent and simplifying situation. And then what is 36 to the 1/2 power, everybody? Nice. Alessandra is the fastest at this. So the final answer is 1 over 6 because of the negative exponent idea and the flipping. So 1 over 36 to the 1/2 is 1 over 6. And actually, in the other class, I did type that on the calculator. So here it is ready for you. 36 caret negative 1/2, 0.16666. Make that a fraction and it's 1/6. Okay, so there's proof that this is 1 over the square root of 36. That's what ends up happening behind the scenes. Hopefully you don't have to use your calculator all the time because then it makes you not know rules. All right, that's actually a truth. Anything to the 0 power is 1. Boom. So that's all I can say about that one. 2/3 raised to the 0 power. Whatever. It's 1. Okay, because anything to the 0 power is 1. So really like this about the negative exponent rule and the 0 exponent rule. It comes from the dividing numbers of the same base. Certain things can happen. All right, and so it created new rules. Okay, now, and it's a perfect day to do this because tomorrow probably won't talk about this too much more. We're going to go back to simplifying radicals and not worry about the fractional exponents too much anymore. But this is today, so we'll tackle these today. 8 times 8. Okay, so what do I do with these exponents? You add them. All right, that's the rule. It doesn't show up as much anymore. Like x squared times x to the third equals x to the fifth. That's easy enough. But when you get these crazy fractional exponents, we lose the rule. All right, so that's the rule we're using because it is numbers of the same base being multiplied together. And then again, I would ask Lexi Samuelis, how would you add these fractions? And the answer is you'd get a common denominator. Not knowing your basics is destructive. So do know how to add fractions and get a common denominator. Hey, what's 3 over 6? Because 5 plus negative 2 is 3 over 6. And the answer is a half, and it's imperative that you do that and simplify your fractions there. Okay, so it would have been nice if 8 to the 1/2 simplifies or evaluates perfectly. Square root of 8 is not perfect. And then don't get into, wait, the square root of 8, I could bust something out of that square root. No, we have fractional exponents to start with, end with fractional exponents. If it doesn't work out perfectly, let's just move on. That's where fractional exponent situations get a little crazy. Like, what do I do from here? How far do I keep going? Do I turn it into a radical and simplify further? Just leave it. And then we'll go back to simplifying square roots tomorrow in a more classical sense. All right, this one's a bit of a problem, but we can actually simplify this first. And actually, that is what you do want to do. When you look on the inside of this parentheses, think of PEMDAS. Okay, I want to clean up the parentheses first before I deal with this exponent. So what do I have to clean up in these parentheses? I have an x over an x. Okay, that can be simplified. I have an x divided by an x. So it is the subtraction rule. So I will have x to the first minus half. Okay, that's what you do when you have x divided by x. You subtract the exponents. Then just write the y and then write the 2/3 because I haven't dealt with those yet. Just going to leave that alone. And I want to take care of this. And actually, this works out very nicely. 1 minus a half is a half. So this becomes x to the 1/2 power. Now I can go ahead and raise this power to the power distributing this. And I'll write this slowly for those that are, not great with fractions, which does make me sad. So I do bring up Lexi Samuels because I get to see my kids now, and I've lamented for years high schoolers that don't know their basics of fractions. And then, well, I got my kid in 4th grade and she's dealing with these things and it's doing great. How do we forget these things? And I think it's just dealing with calculators too much. All right. When I take 2/3 and multiply it by a half, the twos cancel and I end up with x to the 1/3. When I take 2/3 times 3, the threes cancel, and this simply becomes y squared. And then as far as, with fractional exponents, this is the final answer. The only thing you could write is that's the cubed of x times a free y squared, but, we're just going to leave it in those terms and move on. Okay. All right. I forget I wanted to do something here. So I will do that now. Humor me for a second. Happy. And then go to this. Sorry. Control V. I get to see your pictures there. Okay. All right. 2 more. And they are some crazy ones. All right. And remember, your delta math is probably just more basic. It starts off basic. Like I think the first question was 6 squared raised to the 3rd. And that's 6 to the 6th. And I think that's what you write in the delta math, and you don't even have to evaluate. So it's pretty simple. And this one's a strange one. And like the last one, I kind of wanted to look on the inside first and see, can I simplify this? And you really can't, because 3 and 32 don't mesh, and you wouldn't want to get into that anyway. Well, if it was 3 over 3, yes, you would. But 3 and 32 are not numbers of the same base, so you can't subtract exponents. There's nothing you can do on the inside right now to simplify this. So that leaves me with having to take this half power and distribute it. So I end up with 3 to the half, which isn't nice. The square root of 3 does not evaluate nicely. And then in the bottom, I get 32. I'm going to write this again for the fractionally challenged. When I take these two and multiply these, that's what happens when you distribute the power into the fraction. The 2's cancel, okay? Cross cancel. And then this ends up being 32 to the 1/5. Hey, with the hands up in the air, what is 32 to the 1/5 power? Got a couple. Good, good. 2 people. Alessandro, what happened? Okay, it is 2. All right, so you are going to want to simplify when you can. This is 2. This is the 5th root of 32. So 2 times itself 5 times does equal 32. So that is that. The numerator does not. So you just kind of leave it. And in terms of, writing this in simplified fractional exponent form, that mess is actually the answer. There's really not much more you could do. This is equal to the square root of 3 over 2, which, there's nothing you can do with that. So that's it. I got to say about that. Okay, and then last but not least, these questions can be a little bit silly, but you just gotta follow your, steps, and you'll be fine. So, like I said, you kind of look at the parentheses. Is there anything I could do on the inside? And the answer to that is no. a times b to the half. They're both different bases, so there's nothing I can do with that. So then what I have to do is this. This is a PEMDAS situation. I have to take care of that 2/3 power first before I even think about looking at this, because that's just multiply. So that blue is left alone for a second. 2 times a to the half. What I do is I distribute that 2/3 power, and then this becomes a to the 2/3, and then b to the, I'm not writing this anymore. 1/2 times 2/3. The 2's cancel, and I get 1/3 left over. So 1/2 times 2/3 when I distribute that power into the b to the 1/2. So b to the 1/2 raised to the 2/3 is 1/3. And then now that I wrote this and I took care of that, now I can take care of the middle. This is where this gets a little weird, where these answers do end up being a little crazy. What I want to do with these is add these exponents. That's the rule. Then I could put leave that b to the 1/3. So I'm really focusing on this and doing this work because that's the only last thing that can be simplified. A times a, you add the exponents is the rule. All right, and the reason I left the fractions very large with space is some common denominator Lexi Samulus work. All right, and then I could write my final answer. 2a, 3 plus 4, which is 7 over 6. And that's what's weird. You end up with a raised to the 7/6 power. And if you're thinking right, you're thinking, wait a minute, that's a 6th root of a to the 7th. That could be simplified and blah, blah, blah. And that's where fractional exponents get a little nuts. Just close it down and shut it down. You got it in terms of 1a after all of these operations have occurred. So you got it in terms of 1a, and just leave it at that, I guess is the best way to say it. So, like I said, yeah, good. Really looking for us to do our work. Shouldn't take too long. I actually put this due for tomorrow because it really shouldn't take you too long tonight to do it or throughout the day. You don't have an 8th hour, so you're done at 2:30 today. We're not asking a lot of you. So, okay, so I'm going to end that video there. Yeah, screen